Compound probability. If you want to go back over basic probability, that's going to be skill number 40 video in this series. There's going to be two main rules that we want to be aware of when we're calculating probability of two or more things happening. All right, rule number one, probability of two things happening is the probability of the first thing happening times the probability of the second thing happening, given that the first thing has already happened. All right, show you how it works with an example. Choose two random shapes. What's the probability they're both yellow? Find out the probability that the first one is yellow, and find out the probability that the second one is yellow, given that you've already taken a yellow one. Okay, so it'll look like this. There's three favorable outcomes. Okay, this guy, and this guy. The light colored ones are yellow on my screen. I don't know if they're yellow on your screen. So we got 3 chances to get a yellow one divided by 2, 4, 6, 8, 10, 12, 14, 16, 18 total shapes. All right, so the probability that we take a yellow one first is 3 out of 18. Now, when we're calculating the probability for the second shape, we're going to assume that we already took a shape, and we're going to assume that we already took a yellow shape. So we took one of the yellow shapes out. Now, how many favorable outcomes are left? Only 2. How many total shapes were left? 17, because we took one of them out. Okay? So probability that the first shape is yellow times probability that the second shape is yellow, given we already took the first one out. You could do some simplifying before you multiply 3. Divide both of these by 3. I could also divide by 2. So we're going to have, in the end, 1 chance out of 51. Right? 1 chance out of 51 to get 2 yellow shapes if I choose 2 at random. That's approximately a 2% chance. Not very likely. Here's our second rule. Second thing to be aware of. If you are finding the probability that one thing or another thing happens, that's going to be an addition. What's the probability the first thing happens plus what's the probability the second thing happens? And then sometimes we're also going to have to subtract out what I'm going to call a crossover. All right, the probability that both things happen. So, event, choose 2 random shapes. What's the probability that only one of them is yellow? Essentially, I'm asking the question, what's the probability that the first one is yellow plus what's the probability that the second one is yellow? All right, so we can start out as we did before. What's the probability that the first shape is yellow? What's the probability that the first shape is yellow and the second one is not yellow? That will be after you've taken a yellow shape the first time, there will be 15 left that are not yellow. Okay, so this will represent the probability of taking a yellow shape first and then taking a non-yellow shape second. All right, we're going to combine that with what's the probability of not taking a yellow shape first. So that times what's the probability of taking a yellow shape second after we've already taken a non-yellow shape first. 3 chances out of 17. And in this situation, there will be no crossover because we basically calculated probability that we only take the first shape as yellow or probability that we only take the second shape as yellow. Get an answer. Okay? Probably want a calculator to do all this. I don't have a calculator, so I'm going to use a computer. And we're getting 0.294 or approximately 29% chance. All right. So still pretty low. It's not as good as a 50-50 chance, but better than the probability of getting both of them to be yellow. All right, let's look at a different situation. Choose 3 shapes. Calculate the probability that all are red or squares. So I'm going to start by figuring out how can we get a red piece or a square piece. There's 2 different ways that I could do this. First way is a little bit more ridiculous than the second way, but I just want to show you that I get the same answer both times. So first way is I could count up my red shapes. 1, 2, 3, 4, 5, 6 red shapes out of, again, 18. All right, so red probability 6/18. All right, square probability 2, 4, 6, 8, 10. Square 10/18. The probability that I'm red or square is going to be 6/18 plus 10/18. But the problem with that is I double counted my red squares. So I'm also going to need to figure out what's the probability of taking a red square out of this set. And that will be 1, 2, 3, 4 18ths that I need to subtract. Okay, so all together, the probability of taking a piece that is either red or square or both is 12/18. All right, 2/3 of the shapes, 66% are either red or square. Now, I could have gotten to that answer faster if instead of calculating these separately or counting these separately, I work on them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? There are 12 out of the 18 shapes that are either red or square. So that would have been a faster way to get to that probability. Now, that's just the probability of taking one shape and having it be either red or square. I want my first shape and my second shape and my third shape to be red or square. All right, so chances of the first shape being red or square is 12/18 times chances of the second shape being red or square if I already took a red or square out, 11 out of 17. Chances of the third shape, 10 out of 16. And I would get my answer. All right, we got 0.269 approximately, so approximately a 27% chance that all 3 of them will be either red or square. All right. So that is the 2 main rules. And if I want to find out the probability that 2 things can happen, multiply those probabilities. I want to find a probability that one thing or another can happen, I add them, subtract out a crossover. Let's look at one last example, make it a more complicated one. Look at this situation. We're going to let circles represent rock, squares represent paper, triangles represent scissors. Rock, paper, scissors. Rock beats paper, paper beats, or my bad, paper beats rock, rock beats scissors, scissors beat paper. Okay, we got candidate number 1. Kept track of a little bit of the history of the rock, paper, scissors games they do. Candidate number 2, same thing. My question is, what is the probability that the person on the left wins in a rock, paper, scissors match against the person on the right? All right, what's the probability that happens? Okay? So, the toughest thing, same way with permutation and combinations, the toughest thing in dealing with probability is fully defining your situation. What does a win look like? A win looks like this guy chooses rock when that guy chooses scissors. So, rock, scissors. Or this guy chooses scissors when that guy chooses paper. Or this guy chooses paper when that guy chooses rock. All right. So these are my 3 possible winning combinations. Now let me calculate these probabilities. What is the probability that he chooses rock? Half. All right. Half of the time he chooses rock. What is the probability that the other person chooses scissors? 2, 4, 6, 7 out of 14. Also, half of the time that person chooses scissors. Probability that both things happen, 1/2 times 1/2. Okay? 1/4, 25%. So 25% of the time, this person will win if they choose rock, based on the histories. All right, let's look at scissors. 2 out of 12 times we choose scissors over here. 6 out of 14 times choose paper over there. Multiply them together. We're going to get 1/14, which is about 7%. All right. 7% of the time, based on their histories, this guy will win choosing scissors while that guy chooses paper. All right, last option for winning. There's 4 ways to choose paper. Over here, when this guy's choosing rock, doesn't choose it that often, 3 out of 14 times. Again, this victory, 3 times 4 is 12. We got 1/14 again, approximately 7%. Okay. Overall, the probability that person on the left wins is going to be probability they win with rock, plus the probability they win with scissors, plus the probability that they win with paper. All right, so that will be almost 40% of the time. 40% of the time.